everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on how to calculate percent composition. So I'll go through the questions we did in class and explain how I got my answers. All right, so the first one we have here is a sample of a compound is found to contain 3.86 grams of sulfur and 4.08 grams of vanadium. So here I'm not given the formula, which means I can't use the molar masses. I'm just going to use the values that are given to me in the problem here. So the sulfur, I have 3.86 grams of, and the vanadium, I have 4.08 grams of, 4.08 grams. Percent composition is part over whole, so I take the mass of each element and divide by the total. So the first thing I need is the total here. So I just add them together, put them in the calculator, and I get 7.94 grams. So now that I have that, I can just take each of these values, 3.86, divide by 7.94 times 100. And then for the vanadium, I take the 4.08, and again divide by the total, 7.94, and then times that by 100. All right, so I plug this into my calculator, and I want to round to one decimal place. So for the sulfur, I get 48.6% sulfur, and then the rest of this is going to be the 51.4% of vanadium. And then if I add these two together, I get 100%, which means that somewhere I did some math correctly. Hooray and huzzah! All right, next up, we have a compound with 1.77 grams of magnesium, 2.33 grams of sulfur, and 4.66 grams of oxygen. All right, so here we have the same thing. We're not given a formula, so we have to use the masses that we have here. So I have magnesium as my first element here, Mg, and I have 1.77 grams. And then I have sulfur, which I have 2.33 grams. And then lastly, I have some oxygen, of which I have 4.66 grams. All right, so here I know the masses of all the elements, which means that I just need to find the total. So I'm going to add all of these values together. And when I do that, I get 8.76 grams. So now that I have that total value, I just divide each of my masses by the total mass, and then I multiply by 100. So 1.77 grams divided by 8.76, 2.33 grams divided by 8.76 grams times 100, and then 4.66 grams divided by 8.76 grams times 100. All right, and so now I just plug this into my calculator, and if I round to one decimal place, I get 20.2 grams of magnesium, and I get 26.6 grams of sulfur, and I get 53.2 grams of oxygen. And then if we add all these values up again, we shall see that we get 100%, which is great. All right, let's look at another one here. 14.62 gram sample of an aluminum oxygen compound contains 7.73 grams of aluminum. What is the percent composition? All right, so my compound contains aluminum and oxygen. So the aluminum I have is 7.73 grams. And then it tells me that the compound is 14.62 grams. So here, I don't know the mass of the oxygen, but what I do know is the total is 14.62 grams. So what I can do here is I can do 14.62 grams, and from it, I can subtract the amount of aluminum, and then what's left will be the oxygen, which is 6.89 grams. So we have to pay attention to the information that's given to us in the problem. We can't just assume that all of the masses are the masses of the elements. All right, so I've got now both of my masses of my elements, and I was already given the total, so I just divide now. And times that by 100, and then I have 6.89 grams divided by 14.62 grams times 100. Right, and then I'm going to do that math in my calculator, and I end up getting 52.9% aluminum and 47.1% oxygen. And again, those add up to 100%, so that is fantastico. All right, moving on. This is to find the percent composition of lead 2 chromate. So here, I'm not given any values, I'm not given any gram amounts in my problem, but I am given a formula. And since I'm given the formula, here I can use the periodic table and the molar masses to figure out the percent composition. So I have 3 elements here. I have Pb, I have Cr, and I have O. All right, so lead I have 1 of, and then if I consult a periodic table, I will find that the molar mass of lead is 7.02 grams, which gives me a total of 7.02 grams of lead. And then I have chromium, which I have 1 of, and the molar mass of chromium is 52, so I have 52 grams of chromium. And then oxygen, I have 4 of, and each of those has a mass of 16 grams, so I have a total of 64 grams of oxygen. All right, so now I'm right back where I was with the other problems, where I now have the masses of all my elements, so I can just add them together to get a total mass, which is going to be 323.2 total grams. All right, and then now I just divide each of my masses by the total. So I have 207.2 divided by 323.2, and then I have 52 grams divided by 3.23.2 grams, and then I have 64 grams divided by 323.2 grams. And of course, I gotta multiply each of these by 100 because it is a percent, not a decimal. All right, so I'm gonna plug this into my calculator and I get 64.1% lead. Ran out of room, can write smaller. 64.1% lead, and I get 16.1% chromium, and I get 19.8% oxygen. All right, and I add all those up, and I do get 100%. So go team. Circle that there. All right, let's take a look at a couple more examples of this that we've got going on here. All right, it says to find the percent composition of strontium phosphate. So here we have a polyatomic ion. We have this PO4 ion, but we separate into elements. So we don't leave this as PO4. We can't just say we have PO4 times, 2 of them, and then find the percent of PO4. We find the percent of P and we find the percent of O. And we know that it's 2 different elements because they're both capitalized. If it had been P little o, then that would be 1 element, polonium, but it's not. All right, so I have strontium here, and I have 3 of them, and the mass of each of my strontiums are 87.62 grams. So that means that I get a total of 262.86 grams of strontium. And then I have phosphorus, which I have, so I have the phosphorus is 2 times 1, it's supposed to be an arrow, 2 times 1, which is just 2. And each phosphorus has a mass of 30.97 grams. So my total here is going to be 61.94 grams. And then lastly, I have the oxygen. The oxygen, the 2 gets distributed here. So 4 times 2 is 8. So I do 8 times 16 is the mass of each of my oxygens, which gives me a total of 128 grams, which seemed to not want to write. There we go. All right. And so now I find the total by adding it all together, and I get 452.8 grams total. All right, so now I just go back and do my math here. 262.86 divided by 452.8 times 100. And then I have 61.94. 452.8 times 100. And then we have 128 divided by 452.8 times 100. These are all gram values. All right, and then we just plug into the calculator and we get for our strontium 58.1% strontium, and we get 13.7% phosphorus, and we get 28.3% oxygen. All right, so if we add all these together, we do not get 100%. We get 100.1%, which is okay. Sometimes because we only round to one decimal place, it ends up being off by a little bit. You'll get something like 100.1% or 99.9%. That's okay. That just means that there's the rounding just didn't work out the way we wanted it to. But it's still close enough. It's good enough for us. All right, let's look at one last example here. Here again, we have a polyatomic ion. So I'm going to distribute the 2 to that nitrogen here. So I had 1 times 2 is 2 times 14.01 gives me 28.02 grams of nitrogen. Then we have hydrogen here. So 2 times 4 is 8. Mass of hydrogen is 1.01, so I get 8.08 grams. And then I have silicon, which I only have 1 of. There's no parentheses around it, so there's nothing doing there. And I get 28.09 grams. And then I have oxygen, which I have 3 of, times 16 gets me 48 grams. All right, so I have 4 elements this time. It's not a big deal. Just means it's a little bit more adding, add, and the total I get down here is going to be 112.19 grams. All right, so we do the same thing that we've done previously. Divide each one by the mass times 100. We get 8.08 grams divided by 12.19 grams times 100, and then we have 28.09 grams divided by 12.19 grams times 100, and then lastly we have our oxygen at 48 grams divided by the total 112.19 times 100. All right. So we plug this into our calculator and we get that we have 25.0% nitrogen. We have 7.2% hydrogen. We have 25.0% silicon. And the remainder, 42.8%, is oxygen. Right, and then we add all those together and we see that we do in fact get 100% here. Go team. All right, so this has been another episode of Chemistry with Capedia, tutorial edition. I hope you learned something, and until next time, keep on chemin'.